Let's work through question 1 of activity 9, which deals with data from a wholesaler that sells products that are typically used in the food industry. So let's actually read in the data set and just take a look at some of the columns that we have. So we have the type of customer that the wholesaler is selling to, either a restaurant customer or retail customer, the region in Portugal where that customer was located, and then the amount of money that the customer spent on these 6 different types of products here. All right, so our task is to predict the annual spending of fresh vegetables, basically the numbers in the fresh column here, from the annual spending on these other products, and then also the type of customer and region type, so we can better understand the relationships between the types of products that customers are buying. All right, so let's start out by fitting the multiple regression model predicting fresh from all the other variables. So we won't include any interactions yet. We'll just fit the models predicting fresh from all the variables. So we'll do our lm fresh twiddle dot using all the variables in the data set. Data equals to whole. And it wants us to look at a summary and then also the results of drop 1. So we'll do summary and we'll do drop 1 and take a look. So there's our model, the summary, and the result of drop 1. And I actually need to add in that additional argument test equals f, so it'll actually do the test for us. Okay. All right, so part A says that this regression lets us answer the question, is there a difference in the average amount of money spent on fresh vegetables between otherwise identical retail and restaurant customers with respect to the other variables in the model? So how can we answer that question? Well, when we look at the coefficients of our regression model, remember what these coefficients are. They're comments about how the expected value of y differs between two individuals that only differ in the one variable we're looking at but are otherwise identical. So in this case, if I hone in on the coefficient of the indicator variable representing the type of customer, then what this is telling me is the average difference in y between retail and restaurant customers that are otherwise identical. In other words, customers that are in the same region and customers that spend identical amounts for these other 5 products here. So I can answer the question, does there look to be any sort of difference in the average amount of money that retail and restaurant customers spend that are otherwise identical? I see the coefficient is minus 4,000, so on average retail customers are spending $4,000 less on fresh vegetables than the restaurant customers. And it looks like this difference in averages is statistically significant since the p-value is less than 5%. So the coefficient of type retail tells us the difference in the average amount spent on fresh produce between retail customers and restaurant customers. So we see that retail customers spend on average about $4,000 less than restaurant customers. And the difference in spending amounts is statistically significant because the p-value of the indicator variable is less than 5%. Okay, so when we compare two different types of customers, they spend the exact same amount of money on milk, grocery, frozen detergents, and meats. They're living in the same region of Portugal, but one customer is a retail customer, the other one is restaurant. We see that the expected difference in fresh between them is about 4,000, with retail spending less than restaurant, and that difference in averages is statistically significant. All right, so the regression also allows us to probe whether the average amount of money spent varies based on the location of otherwise identical customers. So how do we know what the difference in the average amount of money spent between different regions is? Well, the coefficients of the indicator variables for region tell us this. So what we imagine is that we're comparing otherwise identical customers, so they're either both retail customers or both restaurant customers, and they're both spending the exact same amount of money on these 5 other products. The coefficient of the indicator variable region Oporto is telling us the difference in the expected expenditure between customers living in Oporto and customers living in the reference level, the one that comes first alphabetically, which is Lisbon in this case. So it looks like that among otherwise identical customers, Oporto customers are spending about $900 less than Lisbon customers, and customers living in a different region of Portugal are spending about $1,600 more than Lisbon customers here. So is the difference in averages between these regions statistically significant? We definitely do see some difference here. The averages seem to differ quite a bit. How do we know if that difference is statistically significant? Well, we don't look at the p-values in this case of the indicator variable because these coefficients are just comparing the average value of y between the Oporto customers and the Lisbon customers, or the other customers versus the Lisbon. We want to know if there's any sort of difference, and so that's why we look at drop 1. And we look to see, is there any difference in the average value of fresh between the different levels of region? And no, we see the p-value is bigger than 5%. So even though we do see, relatively pronounced differences in the averages, it turns out that the difference in averages is not statistically significant. I would expect to get that much variation in the averages just by chance alone. So no, the difference in averages is not statistically significant because the p-value of the effect test is bigger than 5%. In this case, it's 25%. So the observed difference in averages between regions is readily explainable by chance variation. All right, so when we compare otherwise identical customers, it doesn't look like it matters which region that customer lives in. All right, question B asks us to extend the model. So the model that we fitted could be potentially overly simplistic because there's no interactions involved. And so without interactions, one thing we know is that the model assumes that the difference in the average value of y when comparing otherwise identical customers that only differ in one particular variable, that difference is a constant. It doesn't matter on what the characteristics of the customers are. And it might be the case that the strength of the relationship between y and x depends on the value of another variable. It might be the case that the difference in the average value of y between different levels of a categorical variable might be relatively big for some values of the other predictors and relatively small for other values. So considering interactions is always a good idea. So part B1 asks us to consider the interaction between milk and type. So let's just fit a regression model predicting fresh from milk and type and their interaction. I don't have to specify milk plus type plus the interaction by just having the two separated by the product symbol. It automatically knows that, hey, you want both of those predictors along with the interaction. So I can fit that model. And what we want to do is we want to visualize that model and then look at a summary. So we'll get a summary and we will visualize that model, putting the legend in the bottom left. Okay, so let's look at the picture first. And what are we asked here? Which type of customer has the stronger relationship between fresh and milk? All right, well, here's the relationship between fresh on the y-axis and milk on the x-axis here. And here are the implicit regression equations for restaurant customers in black and retail customers in red. So by putting in that interaction, we allow the strength of the relationship between the types of customers to potentially be different. And we do see that there looks to be a noticeable difference. It looks like the slope for the restaurant customers is noticeably farther away from 0, implying a stronger relationship than for retail customers. So which type of customer has the stronger relationship? It looks like that restaurant customers have the stronger relationship. The slope is farther from 0. In other words, the line is more tilted here. And what is the difference in the strengths? Well, the difference in the slopes is actually encoded by the coefficient of the indicator or of the interaction variable here. So it looks like the difference in slopes is minus 0.5 here. Is that difference in slopes, is the difference in strength statistically significant? Well, that all hinges on whether this p-value is less than 5%. And we do see that it's less than 5%, so yes, the difference in strengths does look to be statistically significant. So the difference in strengths is statistically significant because the p-value of the interaction term is less than 5%. It's 0.00369. So it looks like the difference in slopes between the types of customers is minus 0.56, with the retail customers having the slope that's closer to 0, because we see that the restaurant customers have a steeper slope here. All right, so that interaction looks important. Now let's consider the interaction between detergents and region. All right, so if I try to predict Fresh from the amount of money they're spending on detergents and the region along with the interaction, let's see what I end up getting. So without the interaction, we're assuming that the strength of the relationship between Fresh and detergents is the same regardless of the type of region I'm looking at, and that may not be the case. Some regions might have a stronger relationship, some regions might have a weaker relationship, and I'll go ahead and put the legend on the bottom left, and I'll add in the summary of the model and also the results of drop 1. Drop 1 because region is a multi-level categorical variable, not just 2 levels, and so to know statistical significance I have to do drop 1 and look at the effect test. Alright, so here's the relationship between Fresh and detergents for the 3 different region types, and we do see that there's a noticeable difference in strengths here. Without the interaction, we assume that the strength of the relationship is the same for each region, so all 3 of these lines are parallel, so by adding in that interaction we've added flexibility, allowing the strengths to potentially be different. And so what we see is that the weakest relationship is with the green line. The slope is closest to 0. That corresponds to regions other. And the steepest relationship, the strongest relationship, is with Lisbon. It's the strongest and it's also the most negative. It looks like that customers that spend more on detergents tend to spend less on fresh produce. Maybe it's a different type of business model. They're either spending money on produce or detergents. So the more you spend on detergents, the less you spend on fresh produce. And it looks like that relationship is strongest for Lisbon here. All right, so it looks like the relationship is strongest for Lisbon customers. The slope is the farthest from 0. In other words, it's the steepest. Turns out to be the most negative in this case. And we want to ask ourselves, okay, so we do see a difference in slopes here, difference in strengths. Is that difference statistically significant? Well, to know whether or not that's the case, we have to look at the effect test. If it was just a 2-level categorical variable, we could just look at the p-value of the interaction term. But now these p-values of the interaction terms are just comparing the strength of the relationship for the variable represented by the indicator, so Oporto, versus the reference level. So we don't see any statistically significant difference between Oporto customers and Lisbon customers, but we want to know if there's an overall difference in strengths. So we look at the p-value of the interaction term as a whole in the effect test, and we see the p-value is bigger than 5%. So actually no, although we do observe a difference in strengths, that difference is not statistically significant. We would expect to see a difference in strengths at least this big just by chance variation. So however, this difference is not statistically significant since the p-value of the effect test is 0.3163. So we expect to see differences in strengths between regions this large just by chance alone, natural sampling variation. All right, so B3 asks us to fit a more complicated model here, predicting Fresh from frozen, region, and milk. So I'll just type those out, frozen plus region plus milk, and the interaction between region and milk. So I can actually go ahead and replace that plus sign by a multiplication sign and write out what data frame we're in. And we got this. And what we're asked to do is write out the implicit regression equations predicting Fresh from frozen and milk for customers in Lisbon and the implicit regression equation for customers in Oporto. So, all right, let's get the summary of that model because we know to write out the implicit regression equations, we always start out with the entirety of the regression equation and then plug in the relevant values. So we have that Fresh is equal to 10,390, that's the intercept, plus 0.9 times Fresh, minus 2595 times Oporto, minus 1623 times other, minus 0.37 times milk, just rounding a little bit, plus 0.056 times Oporto times milk. That's this interaction term right here. and then plus 0.055 times other times milk. That's this interaction term right here. Just a coincidence that these two coefficients happen to be the same. All right, so if I want the implicit regression equation for customers in Lisbon, so for customers in Lisbon, we have that these two indicator variables are equal to 0, because this indicator variable is equal to 1 for Porto customers and 0 otherwise. So we have that Porto equals 0, other equals 0. So we can plug in those relevant values and simplify. So Porto is 0, other is 0, and Porto is 0, other is 0. So I see that this term actually equals 0 because it's 0 times something. This term is 0, this term is 0, and this term is 0 as well. So I actually can simplify this to this equation right here. Okay, so for Lisbon customers, this is the equation that we've essentially fit. And then we want to know the equation for those Porto customers. So there, the indicator variable for Porto is 1, and the indicator variable for other is 0. So once again, we'll start out with the overall regression equation, and we'll just plug in the relevant values. So Porto is 1, other is 0, Porto is 1, other is 0. And now I can simplify a little bit. 10,390 plus 0.9 fresh minus 2,595, because that's times 1. That's 0. Then minus 0.37 times milk plus 0.056 times milk, because 0.056 times 1 is just 0.056. And then this is 0, so I don't have to include it. And now I can simplify. So these two numbers here, the 10,390 and the minus 2,595, can just be added together to be 7,795. And then I have a 0.09 fresh, or 0.9 fresh. And then I have two terms that involve milk. I have a minus 0.37, and then I have a plus 0.056. So combining those coefficients, 0.314 times milk. All right, so that's my implicit regression equation for the Porto customers. So we notice that the intercepts are different between the two regions. We notice that the coefficient of the variable that's not involved in the interaction is the same. We see that the fresh is not involved in that interaction, so both those levels have the same coefficients. But the coefficient for the variable that is involved in the interaction is allowed to be different between regions. So the coefficient of milk is minus 0.37 for Lisbon customers, where it's minus 0.314 for Porto customers. Okay, so the boss decides to use a model predicting fresh from all the other variables along with interactions between these guys right here. So we'll just go ahead and fit that model because the boss told us to. And what we're going to do is we're going to talk about it. So verify that the interaction between region and frozen is statistically significant using drop 1. So we have to look at the results of drop 1 because the p-values of the indicator variables themselves will just be comparing the Lisbon customers to the customers living in the region indicated by the indicator variable. So let's do drop 1 test equals f. So to determine whether or not that interaction between frozen and region is statistically significant, we find that interaction. We look at the p-value of the effect test, and we see that, yes, it is statistically significant. The p-value is less than 5%. So it is, since the p-value of the effect test is 0.003155. And notice, actually, if we had just looked at the coefficients of the interactions in the summary of the model itself, the interaction between frozen and region, we see that we have two p-values that are bigger than 5%. So remember, these p-values are doing something overly specific. It's comparing the strength of the relationship between fresh and frozen for Porto customers to the strength for the reference level for the Lisbon customers. And it's just basically saying, okay, we don't see any difference between Porto and Lisbon. We don't see any difference between other and Lisbon, but we do see a difference overall. It's probably the case that Porto and other customers are the ones that have different strengths. All right, second part says, all right, let's run some C interactions now to see all of the interactions in our model kind of as a whole. So we have a bunch of interactions. We could write out the implicit regression equations, but that's hard. So let's go ahead and run this, and let's not typo it. And here we go. Here are all the interaction plots for all the interactions in our model. I'm going to run that one more time to resize the legends here. And this wants us to determine for which region the relationship between fresh and frozen is the strongest and which are the weakest. So we're assuming otherwise identical customers. They have the exact same values for all the other predictors in the model except for frozen and except for region. So we're going to compare customers that differ in frozen but that are otherwise identical, that say are just living in Lisbon, just living in Oporto, etc., and see how that strength might vary here. So which of these interaction plots do I want to look at? Well, I'm looking at the relationship between fresh and frozen. So I kind of search around here and, all right, well, here's the relationship between fresh and frozen, so that's what I want to be looking at. And here are the three implicit regression lines. So among otherwise identical customers, it looks like that the strength of the relationship between fresh and frozen is strongest for the other region, and the relationship is weakest for the Oporto region. I'm going along with what that analysis was with statistical significance. It turns out the difference in strengths between Lisbon and other, and Lisbon and Oporto, that's not statistically significant, but overall there is a difference in strengths, kind of implying that there is a statistically significant difference between Oporto and other here. So what we see is that the very top left plot shows that the strength of the relationship between fresh and frozen is strongest, basically steepest. The slope is farthest from 0 for other customers living in the region other, and weakest for the Oporto customers. The slope is closest to 0 and the least steep. All right, so there we go. That finishes off number 1. Let's compile this, make sure it compiles. It does, and the key thing is that since you're reading in a data file, you need to make sure that your RMD file that you're editing is in the same directory as the data file that you're reading in here.